Now, I am very happy to be able to announce Geoffrey Martin Rockwell. I've been trying for so many years to get him to the Leipzig Summer School, and this year somehow things come together. So Geoffrey is a professor of philosophy and humanities computing at the University of Alberta. He has published on textual visualization and analysis and computing in the humanities, including a book which he just published at the MIT Press, or the MIT Press published. It's Hermeneutica, Computer-Assisted Interpretation in the Humanities. Perhaps we should all read it. He is a co-developer of Voyant Tools. Some of you perhaps know Voyant Tools, which is a suite of text analysis tools. And he also leads the TAPOR project. And he is currently the director of the Kuhl Institute of Advanced Study, and he blogs also at theoreti.k. Geoffrey will give his talk on replication as a way of knowing in the digital humanities. And I welcome Geoffrey, and I'm thankful that he is here.
Okay, so thank you so much, Elizabeth, for inviting me, and thank you to all the people who have made this possible, all the people who have helped organize this. I have in the past organized institutes much smaller and more modest than this, and I know how much work goes into them. It's a type of care work that makes all of our research and learning possible that often disappears, a little bit like tools and infrastructure. The second thing I'd like to say before I start is I'm not used to having things hang over my ears like this. No. I'm going to be talking about work that I've done with Stefan Sinclair. So this is a joint project. As Elizabeth mentioned, we just published a book together from MIT Press called Hermeneutica. You can go to the website, Hermeneutica, with a period. Some of you know me well, know that I have cornered the Canadian philosophical domain names. I own Epistemologica, which is what this, Ontologica. I had Humanistica, and I gave it to the French group. Anyway, so and so and so. So this is joint. This is our next project together. In 1887, the polymath T.C. Mendenhall published an article in Science titled "The Characteristic Curve of Composition," which is both one of the earliest examples of quantitative stylistics, but also presents one of the first text visualizations. Mendenhall thought that different authors would have distinctive curves of word length frequencies that could help authorship attribution, much like a spectroscope can be used to identify elements. And if you know a spectroscope, you sort of heat up an unknown element, the gases are released, you run light through it, and based on the diffraction of the light, you can sort of tell what might be the composition of this unknown thing. So just as you're trying to figure out what an unknown substance is, he thought that this would give us a way to see what an unknown author is. In this slide, you can see an example of the characteristic curve of Oliver Twist. Mendenhall counted by hand the length of characters of each of the first 1,000 words, and then graphed the number of words for each length. Thus, you can see here that you have the one-letter words, there's 50 of them, there's about 175 two-letter words, three-letter words are the most numerous, close to 250, and so on. Mendenhall's paper led to a commission to use this technique to show that Francis Bacon was really the author of Shakespeare's play. A wealthy Bostonian, Augustus Hemingway, paid for the tedious work of two women who counted the word lengths only to show that no, Bacon was not Shakespeare, or at least Bacon's prose didn't have the curve characteristic of Shakespeare's drama. Mendenhall is not alone in using quantitative methods, though he's one of the first. As Joanne Wagner shows in a fabulous essay, Characteristic Curves and Counting Machines, Assessing Style at the Turn of the Century, mechanistic research processes were attractive, as they are now too, But at that time, they were attractive to rhetoric and stylistics, a new discipline that was trying to establish itself as a scientific discipline. They were negotiating, in the field of rhetoric and stylistics, they were negotiating replicable methods that could give them the status of something like a scientific discipline. You won't be surprised to find out that once the computer came along, all sorts of other people began to, inspired by Mendenhall's experiments, began to play with different quantitative approaches, including his one. Anthony Kenny starts his book, The Computation of Style, which dates back to 1982, not with Father Bouza, who is traditionally considered the founder of humanities computing, but by discussing how Mendenhall and pre-computing contemporaries proposed and tried different stylistic tests, developing a field that then benefited from the availability of electronic computers after World War II. Anthony Kenny, by the way, also, he was a very well-known Aristotle scholar, philosopher, Aristotle scholar. He wrote a book. He worked with Susan Hawkey and wrote a book. I think he was using the mainframe version of the Oxford Concording Program and wrote a book on some of Aristotle's works. I think it was the Nicomachean Ethics, using various quantitative methods. So he was also in some ways an early pioneer in the digital humanities, or as we called it back then, humanities computing. With a computer, it became possible not only to do statistics faster, but also to gather statistics automatically by computer and from electronic text. With a dramatic increase in available e-text, quantitative studies have exploded, and some have even returned to Mendenhall. As recently as 2009, Marlowe fan Daryl Pinkson, in a blog essay, replicated Mendenhall's technique using a computer to show that while Bacon may not look like Shakespeare, Marlowe does. And this is from Pinkson's blog entry, in which he superimposed a number of different curves from Shakespeare and from Marlowe. So we have this technique that is still being used. Admittedly, I think most people are skeptical of it, but it's still being used more than 100 years later. And that's what this chapter is about, this paper is about. It is going to become a chapter at some point. The replication of text analysis techniques is a way of thinking through the history and possibilities for computer-assisted text analysis. This presentation proposes replication as one way of doing the history of computing that thinks through computing rather than only about computing. I'm going to illustrate the proposal that Stefan and I are putting forward today by discussing two replication studies, that of Mendenhall and that of another early analytic method used by John B. Smith on James Joyce. These two experiments are in turn replicated as interactive IPython notebooks, and I'll also be showing you Mathematica versions of them so that you can actually, if you want to, download them, fork them, and try them yourself in a sort of ongoing chain of replication. And I'm going to, on the way, talk a little bit about how I see replication as a way of paying attention to a lot of the care work that happens in the digital humanities, another type of care work, the care work that goes into the building of tools, and that often disappears when those tools are no longer available, tools and methods. So one way to understand the history of analytical methods in the digital humanities is to try to replicate them. Historical replication is not the same as scientific reproducibility. Reproducibility in the sciences is ostensibly about guaranteeing results by testing them in order to advance science. Historical replication, when you take a process, a method, and try to reproduce it in code or manually, historical replication is a way of understanding the outcomes, practices, and contexts of historical works by deliberately following through their activities of research. As such, it is a reply. In English, the word ply means to fold. It's a sort of refolding, if you will, folding back on itself to engage practices of the past as if they were relevant today and not simply to be glossed over in a historical note. Is one of the many ways to conjure up the context of historical moments to aid understanding understanding a fundamental humanities impulse. It is, if you will, a form of philologie, or the love of logos. In this case, the logos of procedure, not of words. Of course, scientific replication is not as simple as the story that is told about how replication works in the sciences. It's not as simple as objectively guaranteeing experimental results. As Collins points out in a lovely article from 1975, The Seven Sexes, a study in the sociology of a phenomena, or the replication of experiments in physics. And for those of you who are science fiction fans, The Seven Sexes comes from a Kurt Vonnegut novel. And I'll leave you to ponder that. Collins describes how successful replication in the sciences, or even failure to confirm experimental results, is not an algorithm that can be run by independent scientists. You can't simply take some articles, try to reproduce how this was done, and sort of say yes or no, this, either that it worked or didn't work. In fact, there are just too many parameters to fully describe an experiment, leaving aside the competitive secretness of labs, and instead what happens in new areas is a process of enculturation when our community negotiates what will count as competent experiments. And you'll recognize this is one of a number of moves in which sociologists and philosophers of technology and science have pointed out how science is not quite as simple and as objective as it gets taught in schools. I think the scientists know this, but the story that we were taught, or I was taught as a kid, was different. It is this negotiated replication that I'm proposing to you as a way of developing communal knowing in the digital humanities. It is the making of a methods commons, to quote, or to paraphrase Willard McCarty. So let's look a second at replication and what it might be able to do. To replicate, or to fold back, is more than just an adjustment of direction or a turning. It is to enter into a dialogical relationship with the work of the past to negotiate what we have in common. It is to reply to the past by trying to recreate the original study or practice, an impossible act. You can never recreate what is past. The past is past. Nonetheless, by trying to do this, you can reanimate it in ways that help in your understanding. Obviously, the past can't speak, which is why we replicate it or reanimate the practices, taking them seriously as we do. What we get, incidentally, are monsters, not replicants. And you may have seen, I hope you all recognize the Blade Runner reference there. The old sense of the word monster is what Frankenstein is a hybrid that is stitched together out of parts, and that's sort of what you get when you do this type of work. We get monsters like Frankenstein's monster stitched together from what is at hand, and what is at hand is just as important, as that is what makes the present common to the past. Replication is important to methods, since the way method brings truth to bear on new work is through the replication of a process to new matters. A method isn't a method if there isn't something replicated across applications of that method. The process is tested and known through reapplication, and it might be more accurate to say that it is negotiated through fiddling around with reapplication. In the scientific use of established methods, there's a knowing that comes from reusing methods that are considered competent. And this is this process of enculturation. In sciences, especially in the early phases, there is the development of a consensus around what constitutes a competent reproduction of an experiment. And the Collins article I mentioned before is quite interesting about how that competency is negotiated. Historical replication, as Stefan and I imagine it, does not necessarily apply established methods to new matters, but seeks to recover, looking back, and understand and reflect on a tradition of methods by reanimating them. The analytical methods of Mendenhall and other historical figures who are no longer used in the digital humanities, but the methods are no longer used, though perhaps we could say their children are, It is the reanimation of these methods that helps us understand how these methods have evolved. They allow us to sort of go back and get some sense of the genetic evolution. It is a way, if you will, of practicing media archaeology, though it might be more accurate to talk about this as method archaeology. So much for the sort of distant gaze of the theory. Up close, doing it, and practically speaking, I propose replication as an interpretive practice that can serve both heuristic and epistemological purposes, that extend our horizons of understanding. Heuristic, because replication is a way of experimenting with old methods, made new in a way that can lead to unexpected insights into the everyday practices of computing, both as they were practiced then and as they could be practiced today. To paraphrase Vannevar Bush, as we may think. Heuristic also because such replications, if documented properly, are a way of sharing research tactics so that they can become the subject of further discussion, experimentation, recombination. And finally, of course, they can be used in teaching the discipline, yet another form of reproduction or replication. So here, for example, just on the subject of, we have built a set of, Stefan and I have built a set of IPython notebooks called The Art of Literary Text Analysis. These are not so much historical, but they replicate a set of, for those of you who know IPython, and I can show it later on, they have code and text interwoven, explaining chunks of code and various key methods that you need to know. And we use this in actually teaching an introduction to humanities computing, at least programming in humanities computing. And I'm going to, well, later on I'm going to show you Mathematica, which is another environment in which you can do this sort of work. Replication also serves epistemological purposes because it allows us to better imagine the mix of concepts and methods that constituted knowing in another time rather than impose our paradigms of knowing. We view this as an experimental extension of Ian Hacking's historical ontology, which builds in turn on Foucault's archaeology of ideas. And the idea is that you know, it's always dangerous to apply today's concepts to what was happening before. And you need ways of trying to understand the concepts, methods, practices of an earlier time. And we believe this form of historical replication is one way of trying to push back that envelope or that horizon of understanding to understand how computing was done, for example, at a time when there weren't computers, as in the case of Mendenhall. What makes replication particularly relevant is that we can consider it a research practice of the digital humanities, which, as a discipline, has gifted us more tools, methods, has gifted us tools, methods, and standards, more so than discourse. And this is one of the threads going through what I want to sort of talk about is many of the things that have been built in the digital humanities disappear because they're not published. I was taking notes for my wiki on the lovely projects that were being presented before. Some of those projects will be gone in 10 years in a way that articles won't. And what we're left with, if you try to do the history of computing in the humanities, you find what we're left with is mostly articles and a little bit of ephemera, but the tools and methods have vanished. And yet, it's these tools and methods that are the most important to some of us, or certainly are crucial to the field. If we want to understand these gifts, we need to understand them as they were meant to be used, not just read about them. In the spirit of interpreting things by following hints for interpretation from the phenomenon itself, we need to be sensitive to the discussions of method in these tools, or at least in the documentation surrounding these tools. These discussions of method hint at replication, as they often describe methods in the hopes that somebody will replicate or try them again later on, or try them in a different context. So, what does this actually do? What does it look like? What does this activity of replication practice? So in the next two sections, I'm going to take you through two experiments of ours on replication. And as I said, the IPython notebooks are up there, so you can always go in and fork them and try them out yourself. The first one is this replication of Mendenhall's characteristic curve. This is, what you're seeing here is our first attempt at replicating it, and this is in an environment called Mathematica. Mathematica is gorgeous. It's absolutely one of the most beautiful but expensive environments out there, which is one reason why we've shifted our practice over to IPython, because that's free and open. But Mathematica is a really beautifully designed environment for this type of analytical work. And what you're seeing here is we have the characteristic curve for Oliver Twist. Then we have On Liberty. Both of these are from Gutenberg, and then we superimpose them. And in the superimposition, you can see that the curves for these texts are in fact different. One of the questions we had was, is this method just going to produce the same sort of curve for any English prose text? Is it really more about language than about individual texts? And no, we could actually find, as we went through, different versions of this. So now I want to talk about some of the things that some of the inferences or some of the thinking that happened as we went through this experiment of replication. Our first observation is not about the method itself so much as the agenda of the method. Mendenhall's, and you'll remember Heidegger uses the word agenda, it's understanding what someone thought they were trying to do at the time. Because often with these tools, the agenda of the creator is very different than what you're using the tool for. Mendenhall's very project today strikes us as a very unusual way of knowing about text through quantification. Why this fascination with authorship and style? And it isn't just Mendenhall. Up until the 1980s, stylistic was what many textual scholars did with computers to text. One reason for the interest in authorship is that it was an important task in the humanities, going back to the likes of Valla and attempts in the Italian Renaissance by Italian Renaissance humanists to recover the classical textual heritage. If concern with authorship now seems to be the purview of forensics or a very sort of small subset of the digital humanities, it's because of the work of humanists stabilizing the archive. They, in some ways, were so successful at stabilizing it and working out the authorship that we no longer worry about this the way they used to. And now we use computers and quantification not to do the traditional work of humanists, but we've extended it to ask new questions. And I think in distant reading, we're doing almost a version of stylistics, but on a whole different scale. We're looking at genres instead of authors and so on. A second observation has to do with the technology of the day. Now, this is going to seem obvious, but when you actually when you think about what it was like to do computing back then, you realize that we take interactive visualizations for granted. And those may in turn authorize a type of interactive interpretive practices, which we also take for granted because it's so easy to take a text and throw it at a tool like Voyant, which I hope you will all try, at least to get our numbers up. Before the personal workstation, be it terminal or computer, the humanists used computers in a batch mode which privileged different types of practices. Batch work calls for a formalization of the entire and expensive process imagined, a practice very different from the throw your text at a data wall and see what sticks approach that's possible with the modern interactive tools. And what you're seeing here is a flowchart from the Prora manual. So this is 1966. And what you have up there is the literary text and various specifications come in. The scholar, he's not sitting at a computer. He's sitting there at a table and he's going through and identifying what constitutes a word and so like that. And then here we have the key punch operator. So all that text is being entered in, and then finally what comes out is a bunch of cars. So there's no screen there, something like that. And it's useful to remember that the people, many of the pioneers in our field, were not working with with computing the way we think of computing. So back to stylistics. And this, by the way, is Voyant. So this is sort of where we are. This is one environment. You know, you go to Voyant Tools. It's actually out of beta now, so you don't even need the beta there. And you upload a text, and boom, it throws all these interactive visualizations at you. You just start clicking away. You can't break anything. There's no key punch operator or anything like that. It shouldn't surprise us that stylistics was presented by Mendenhall and successors as a way to bring scientific reliability of mechanical processes to the study of rhetoric. Mendenhall compared his visualizations to the curves produced by spectrographic analysis of materials. It wasn't just scientific method that was brought to stylistics. Mendenhall also brought the rhetoric of scientific visualizations as evidence to the rhetoric and stylistics. Visualization is a way of knowing about which we don't know a lot, but we've been borrowing it from the sciences. I think it's becoming very important right now, and it's something, but we see even in Mendenhall, we see this sort of borrowing that happens. Here's an example of a spectrograph from a scientific website. And I guess one of the things I'm trying to say is that the visualizations that we use today, whether it's these types of histograms or even network graphs, all of them have histories of being interpreted, and these histories goes back into scientific uses in many cases. The family tree would be a more humanities alternative. And we've inherited a lot of these assumptions, and this is a point that Johanna Drucker makes quite vividly in books like Graphesis. We've inherited them without applying the same sort of humanistic criticism that we would apply to other inherited ideas. And so this, in some ways, I'm just sort of emphasizing a point that she makes. That said, one thing we did not do in our efforts to replicate Mendenhall was actually count the words by hand. Much could be said about how we have a critical mass of e-text available now. I'm going to confine myself to one point following Lauren Klein, and I want to note that our relationship with data has changed. Until recently, data had to be made manually. Remember that key punch operator? If any of you have seen the photographs of Booza's lab, he had a space bigger than this room full of, I think at one point he was employing as many as 50 to 70 women doing the key punch operating. That is a very different relationship to data. Now, data presents itself as a given, something that is ready at hand to be downloaded. You can get more data than you possibly need. If you know how to set up a scraper, you can send it out to grab web pages or to, the Twitter API and stuff like that. Whatever questions you have, you can probably get more data than easily within a day or so. You can get more data than you know what to do with, or you can analyze easily with the tools that are at hand. And this is a dramatic change in how we think about our projects. The data is almost a given in the other sense of something that beyond which we cannot go. While people like Kitchen like to complain about the etymological origin of the word data, in Latin for given, I actually believe that it really suits the current approach that we have to data, because it emphasizes the contemporary epistemological habit of treating data and the infrastructure that hoses us with data as that invisible, which is just given, like the roads. We know they're there, we just get in our car, we don't sit there and go, oh my God, did the roads disappear last night? No, we know that there's a road to get from here to there, and maybe the lights are down, or there's a detour or something like that, but we take it as a given. And this is something that was not true until recently, really until I would say about it's hard to say when. I'm going to say Google Books is a sort of defining point there, when all of a sudden there seems to be more data than we know what to do with. It's a given the way electricity is. No one really bothers to question electricity or poke into the data, except, of course, we in the digital humanities. We know that data is a gift horse whose teeth you should check very carefully before riding off into the sunset of insight. Instead of counting word lengths by hand, we treated Mendenhall, as Kenny does, as being at the beginning of a tradition of quantitative stylistics that saw fulfillment in automation. Replicating Mendenhall on a computer can seem like a way of appropriating his works to computing. And that is also one of the points we want to make about the history of computing. It stretches back beyond the development of electronic computers. If you wanted to understand computing in the humanities, you need to understand the importance of stylistics and quantitative methods before there were computers. People were doing this stuff by hand. And when computers came along, it seemed like a godsend to them. If you will, if you consider Mendenhall to be the founder of quantitative stylistics, it changes our founding story of humanities computing. The cosmology story of humanities computing usually starts with Father Buza's mid-20th century efforts to produce a computerized concordance of the works of Thomas Aquinas. But Mendenhall and others predate Buza by half a century. This, by the way, I was at the Buza archives at La Cattolica in Milan about 4 months ago, which are fabulous. I mean, if you're interested in the history of the digital humanities, he was a pack rat, and he kept amazing amounts of stuff. This is what does he call it, an organigramma, and it's part of a proposal to IBM to rush the Index Thomisticus to have a big chunk of it done for the New York Fair in 1964. And the new IBM had a big pavilion. You can go onto YouTube and you can find they had a very iconic pavilion in 1964. Buza's index was not there, but he produced this report. So it's one of the few, it's a fabulous sort of picture into how many people he had to hire, what he saw as the sort of process going through that. And I've written a long blog entry about some of about the Buza project as project. And for all of you who are starting or finishing or somewhere in the messy middle of digital humanities projects, you may enjoy reading about the project to end all projects because his was a massive one. Anyway, my point is simply that, this gets taken as our origin story, as our, genesis, if you will. But there are a whole mess of other origin stories, and if you've read there are other people sort of unpacking some of the other ones that are out there. Another point to be made about Mendenhall is one that Joanne Wagner, who I mentioned before, points out, and that is that one of the assumptions behind stylistics as practiced by Mendenhall is that style is character, in the strong sense that it is the man. You are defined by your style. And further, that an author typically can't alter their fundamental characteristics consciously. This is a fascinating claim. And there's all sorts of interesting questions and problems to dig into. In some ways, I think stylistics has not been fully explored. We sort of detoured off, and that's another story, I think, though I think it's due to Stanley Fish. And it's time in some ways to come back. Stylistics has fallen out of favor, but I believe it's actually returning in a new register and with a vengeance in various forms of algorithmic profiling and predictive analytics. A lot of the algorithms that are being used by in industry, by insurance companies and stuff like that, what they are trying to do is to figure out your character and to figure out what you're up to in your thinking and what you want to buy and then influence it. So in a funny way, stylistics has made a comeback through that. And of course, the NSA, we know from Snowden, if we can believe him, that the NSA is trying to build predictive systems, which is again about character. What sort of character are you, and are you likely to do something stupid? In fact, going back to Mendenhall, what's interesting is that we actually get a different curve if we take the entire Oliver Twist than just the first 1,000 words. And right here you see some of the problems with the early attempts at stylistics is they couldn't get enough data. There are other problems when you have too much data, but Mendenhall himself, if you actually take him at his word, and as we did, sort of try to replicate this in various ways, you discover that that even the curve that he says is there is not really the curve that is there. What does it mean if an author has a different curve or uses two-letter words more often? It would probably be more accurate to think of stylistics as being about discourse, not people, or as Sally Sedlow put it in 1969, characterizing the language usage of any writer or speaker. And the final point I want to say about which any of you who have done any programming and text analysis know is, of course, it's remarkably hard to formally describe a word. In our IPython notebook version, we use the Natural Language Toolkit, the NLTK for Python, and its method for recognizing words in a text tokenization. So many of the decisions as to what are word boundaries, what are the boundaries for a word, what to do, for example, with hyphens and apostrophes, and what to do with abbreviations are hidden, even from us. We have the programming tools we use have these layers upon layers, and something as simple as what is a word can be hidden, and you may not know exactly what it's doing in terms of deciding what a word is in English or in a different language. Tokenizing into words is nonetheless a fundamental step in almost all text analysis processes. Bag of words is all over the place. It is a step that is language specific. In English, text analysis benefits from the rough correlation between words as concepts and words as orthographic words or strings that we can use the computer to tokenize. And this is, I think, one of the features that has made text analysis popular in the English-speaking world, because there is a loose correlation between the conceptual word and the orthographic word. Okay, so now I'm going to switch to my second example, which is John B. Smith, Image and Imagery in Joyce's Portrait. So this is the second case of a visualization that Stefan Sinclair and I tried to reproduce. Smith's article from 1973 is a gem of a paper that uses text analysis to test an aesthetics theory drawn from the novel back onto the novel itself. So Smith takes, from Joyce's portrait, he draws a sort of theory about how to interpret Joyce's portrait, and then computerizes it and applies it back to the novel. So in that sense, Smith's work is not stylistics, it's much more hermeneutical. He is developing a theory in some ways adapted to the text that he's studying. I should mention that Smith was a pioneer in all sorts of ways. He was a pioneer in developing and theorizing interactive tools meant for interpretive use. He was Sally Sedilow's student and helped her teach the first NEH-funded workshop for faculty to learn about using computers in the humanities in the United States. And if any of you were at DH, we heard an NEH program officer who was awarded the Buza Prize talking about some of these early awards. And I'm fairly sure she's talking about awards to Sally Sedilow, who, along with her husband, was one of the sort of pioneers, at least in the States, especially in teaching these types of materials. In the 1970s, he built on Sally Sedilow's work and developed the RATS utilities. He had a sense of humor, RATS, on which he published in Computing the Humanities in '72. In 1978, he published a theory of computer criticism in which he showed all sorts of visualizations. He was really one of the first to do visualizations of text with computers in the humanities. And in the 1980s, he developed ARAS, the first interactive as opposed to batch text analysis environment, a tool that influenced TACT, Hyperpo, Tupperware, Voyant. It had a tremendous impact downstream on the way we imagine the tools that we're going to use. I'm guessing that none of you, or very few of you, have heard of Smith or ARAS, and I'm going to return to that later, how we've lost an important part of our history. So what did he discover from this visualization? Well, so this is a sort of excerpt of what Smith had to say examining the graph. An examination of the graph shows that the richest scene in the novel in terms of imagery is the Pandybat episode at the end of chapter 1. And that's what I've sort of circled there. If we look closely at the base of the peak, we can see that it tops a long, sustained buildup in the intensity of the imagery. This pattern suggests why some experiences reach epiphanal intensity while others subside before that point. Now, some of you are probably wondering what a Pandybat is. And a Pandybat is a handle with a stiff leather strap that was used to punish young boys in Ireland. I have spent a lot of time Googling trying to find an example of a Pandybat that does not come from a bondage site. And I want you to know, and this is it. But if you know Portrait, the Pandybat scene is this moment when the young narrator hero is punished unjustly with the Pandybat. And it is an emotionally very intense scene, and in effect, what Smith is saying is that using this approach of tracking imagery, we can actually see the intensity of imagery, and we can see the spike in what is, many would agree, one of the most sort of intense moments of the actual, of the novel. In terms of process, what Smith did in Image and Imagery was to use a custom dictionary of some 1,300 terms with emotional valence to track and visualize image intensity through the novel. He divided the text into 500-word chunks, approximately the number of words on a page, as he puts it. Then he had the computer account the number of imagery words from his dictionary in each chunk, weighting some words as more significant and graphing the results. And that's what you see. And here is now our recreation of that. And of course, if you think about it, you can imagine, well, first of all, you'll notice that we don't have the spike that he had. Our graph doesn't quite look the same. And a second problem we had, of course, were these 1,300 words. He had this custom dictionary. The custom dictionary is not in the article. He happens to be alive, so we called him up and said, where can we find your 1,300 words? Well, it turned out that he had actually, he pointed us to, he had published his thesis, which had an appendix. We were able to scan that in, and we were able to get something that was a little bit closer, but still not similar to, you can see some of the differences between our graph and his graph. So there's a number of reasons why we might, in good faith, not get the same result as Smith did. And our addition was different. What counts as a word is different. The chunk boundaries could be different. And while we know Smith weighted some words he thought were important, we don't know which ones. Further, the appendix of words that we got from his sort of published thesis may not be the same 1,300 words that he actually used in that study, because, you know, he may have sort of evolved his list in conversation with people and so on like that. We actually suspect it's the weighting, and we're now doing a bunch of experiments to see if we can start weighting different words and get something closer to his thing. But you can see all of a sudden how our historical replication is not designed to prove that Smith was right. It's designed to recover an understanding of what Smith thought he was doing at that time without asking him. The shape and success of historical replications may in some cases depend on coincidences and conveniences, such as a historical interlocutor who can actually provide guidance. And we're acutely aware of the contingencies of such an approach. Each replication is a deformation, as Jerry McGann would say. And this raises a question of whether or not replication's goal should be complete and faithful reenactment. And in our case, we've decided it shouldn't be. It's more about trying to understand what they were doing than getting a precise and accurate reproduction of the original. As I mentioned, when we read about replication and reproducibility in the sciences, we find, in fact, that things are negotiated. And that's what we're doing, is we see this as more a sort of negotiation with the past. Historical replication, as we're practicing it, is designed to help us understand the human details of a method, not reproduce it accurately. So I now want to show you, so this is, I want to talk about the notebooks, and then I'm going to wrap up. Let me just check my time here. So this is our original Mathematica notebook, and if you bear with me a sec, I'll actually escape from this and show you Mathematica. So this is Mathematica. I've sort of zoomed out. It is a lovely environment. If any of you have it's a sort of a word processing environment. You can collapse and expand things. This area over here allows you to control various things. You can type whatever you want, and then you're getting, as you put chunks of code, and the code outputs results. The results can then be manipulated until you get further results, and you can store, if you will, a sort of, or you can collapse and expand things, and you can store, if you will, a record of a series of a complicated experiment like these types of replications that we're trying to do. So that's Mathematica. The downside of Mathematica is that it costs money, and it's an expensive annual license, and if your university has not bought an institutional license, then it's probably not worth playing around with it. So, literate programming. So this whole model comes from Donald Knuth and an idea of literate programming. Literate programming was first described by Donald Knuth, and he is sort of the grandfather of algorithms. You know, his book on algorithms is still, in computer science, is still very well known. It was described by Donald Knuth in 1984 as an alternative to structured programming, which drove him crazy. I'm not sure why. I've always liked structured programming, but anyway. Literate programming emphasizes the primacy of thinking through in a literate or human-readable fashion what a program should do. As Knuth put it, instead of imagining that our main task is to instruct a computer what to do, let us concentrate rather on explaining to human beings what we want the computer to do. So think about it. It's a form of programming designed to be read by other humans, more importantly than driving the computer. And Mathematica, released in 1988, was one of the first environments to take up this idea, and it's been evolving, and it's really quite a magnificent environment. Nowadays, we've seen an explosion of these notebook environments, and so IPython is one of them. There's a version of R, and other people are using this. This, for example, is from Matt Wilkins. He uses IPython. He gives these lovely papers. You can read the paper, and then you can see the code, and he actually has a link to his data so you can recapitulate it. Literate programming is particularly suited to humanities computing as it privileges human reading and experimentation, which in turn encourages understanding of methods through experimentation. These replications are therefore also experiments towards what Willard McCarthy calls a methods commons for the sharing of methods and code. You can take Matt's code, you can take his data, you can fork it, and then you can play with it and run it again. And this way of sort of combining the rhetorical, the actual sort of procedure written in code and the data in a way that is shared is in effect what we're promoting and trying to suggest is important here. A variant on that is, Elizabeth was kind enough to mention our book, Hermeneutica. And if you go to the website Hermeneutica, I told you I had cornered the market on philosophical Canadian domain names. You can see some of the chapters, and in those chapters we do another form of replication where we actually have embedded Voyant panels where you can actually play with the interactive panels. So that's more of a sort of embedded, it's not quite literary programming, but it's a different approach of embedding stuff. So I think I'm going to stop at this particular point. I'm going to mention what historical replication is not good at, and then call it a day. Historical replication of the sort we're proposing is not good at interactive environments. And I mentioned before that John B. Smith developed ERAS, one of the first interactive text analysis environments. He had what at the time was a really original idea, that people, when they do interpretation of an electronic text, it's not a batch process. It's more a series of sort of iterative question asking, and he developed software, ERAS, which ran on an IBM mainframe, that supported this sort of interactive question answering, and it allowed you, because it was time sharing, it allowed you to actually switch back and forth through your word processor. We take this for granted now, but it was an innovation at the time. First of all, to use time sharing to switch back and forth. Secondly, to have an environment which was dialogical, if you will. He developed his own command language, which had sort of philosophical components. ERAS does not exist anymore. I've never been able to see it. And you can't actually replicate it with this sort of historical approach that I'm suggesting with these notebooks, because what you're trying to replicate is something interactive. We would have to simulate it. We'd have to build a simulation, if you will, of the final thing. And that is to make this point again, that some of those interesting innovations in our field are lost in a way that cannot be recovered unless we're willing to start simulating things. And in terms of how we know about our own field and how we know about computing. Baird, in his book Thing Knowledge, makes a very interesting point about how the importance, especially he's talking about the field of science and something like that, the importance of the things and the knowledge that they bear. And these software packages and these methods bears forms of knowledge which we are losing. Thank you very much. These are the links to the GitHub 2 notebooks if you want to go in and look at them.